Perpendicular and angle bisectors. First, we need to talk about how to measure the distance from a point to a line. If I asked you to find the distance from this point to this line, how would you measure that? Would you find the length of this segment, or this one, or this one, or this one? We can find infinitely many distances from this point to this line, especially because this line is going to go on forever. So in order to have a consistent measurement, regardless of who is measuring this and how many times you're measuring it, we need a definition. So you can find the distance from a point to a line by finding the length of the perpendicular segment from the point to that line. This is actually going to be the shortest distance. So from the point, if you bring down a perpendicular segment to the line, the length of this blue segment would be the official distance from this point to this line. A perpendicular bisector is a segment, ray, line, or plane that is perpendicular to a segment at its midpoint. So here we have line CP is a perpendicular bisector of segment AB because it goes through the midpoint P and it's also perpendicular to that segment. The perpendicular bisector theorem states that a point is on the perpendicular bisector of a segment if and only if it is equidistant from the endpoints of a segment. So again, this theorem is given to you as a biconditional, which means the conditional and the converse is true. So for the conditional, if CP is the perpendicular bisector of AB, then we have that the length of CA is going to be equal to the length of CB. The converse states that if you have segment DA is congruent to DB, so that means there's some point D where that length from DA to DB is going to be congruent, then that point D must be on the perpendicular bisector of AB. So we're going to go ahead and put that perpendicular bisector theorem into practice here using the diagram and answering the questions below. It says that MO is the perpendicular bisector of what segment? So here we have segment MO, and it is perpendicular, and it cuts through the midpoint of segment NP, because NP gets cut into two congruent parts. So MO is the perpendicular bisector of segment NP. Then it asks us what the length of MP is. Remember, it says that any point on the perpendicular bisector is going to be equidistant from the endpoints of the segment it bisected. So the length of NP is going to be congruent to the length of MN. Since MN is 4.5, MP will also be 4.5. Next, we need to find the length of segment NO. So here's segment NO, and O is actually a point on the perpendicular bisector as well. So that's going to be the same distance as OP. So since OP is 9.5, NO is also 9.5. And then lastly, it asks for the length of segment NP. NP is the entire length of the segment that got bisected. Since this half is 3.2, the other half is also 3.2. So total NP is going to be 6.4. Now we've talked about angle bisectors before, but just to review, an angle bisector is a segment, ray, line, or a plane that bisects an angle. So here we have line RT is the angle bisector of angle QRS. So that means it cuts the angle in half, so that angle QRT is going to be congruent to angle TRS. Here we have the angle bisector theorem, which states that a point is on the bisector of an angle if and only if it is equidistant from the two sides of the angle. So again, we have this biconditional, so the conditional and the converse of the theorem are both true. For the conditional, it states that if the measure of angle BAC, so BAC, that's this angle here, is equal to the measure of angle CAD, CAD that's this angle here, then we can say that point C is going to be equidistant from the sides of the angle. So remember, this brings in our definition of the distance from a point to a line. So from point C, if we bring the perpendicular segment out to AB and measure that length, and find the perpendicular segment from point C out to line AD and find that length, we'll find that those two lengths are going to be congruent. Likewise, if there is some point R so that the length of RP is equal to RT, then we can say that the measure of angle PAR is going to be equal to the measure of angle RAT. So let's go ahead and put that theorem into practice here. The first question asks us, how far is M from KL? So here's point M, and here's segment KL. Now remember, we define the distance from a point to a line as the length of the perpendicular segment. So ML, this is the perpendicular segment from point M to that line. So we would say that M, the distance from M to KL is going to be 8. It also asks the question, how far is M from JK? So likewise, we want to find that perpendicular segment to segment JK, and because it's congruent to ML, we can say that it's also 8 long. Next, it asks us how segment KM is related to angle JKL. So here we have angle JKL, and then here we have segment KM. Now, the converse of the angle bisector theorem says that if you have a point that is equidistant from the sides of an angle, then those two angles, JKM and MKL, are going to be congruent. So MK is actually the angle bisector of angle JKL. So we can say that KM is the angle bisector of angle JKL. That leads us into question 4. Question 4 asks for the value of x. So now that we know that these two angles are congruent, we can actually say that 3x is equal to 54. So we set up this equation because they're congruent, and then we can divide by 3, and then we get x is equal to 18. Now it asks us for the measure of angle JMK. The measure of angle JMK is actually up here. Now the way we're going to find the measure of that angle is here we have this triangle that we want to focus on. We know that the measure of this angle is going to be 54 degrees. We know that this angle is 90, so all we need to do is find this remaining angle. I'm just going to label it with the y. So you know the three angles of a triangle add up to 180. So 90 plus y plus 54 equals 180. So in solving this equation, we have y plus 144 is equal to 180. And then when you subtract 144 from both sides, we have y is equal to 36. So the measure of angle JMK is going to be 36 degrees. That's it for this lesson on perpendicular and angle bisectors.